All right, so proportional reasoning. So remember that ratio is a comparison of two numbers by division, and a proportion is an equation that has two ratios that are equal to each other. So here we've got the cross product property. You probably remember this. Oops. All right. Where we just basically cross multiply. How many of you remember cross multiplying? Okay. All right. So the first part of this should go rather quickly. So I'll do letter A, and then you guys can do letter B. So letter A, when we cross multiply, that means we're going to multiply 16 times 12.9. And then multiply P times 24. And those things then are equal to each other. Elise?
Do we have our calculator? You would have wrote these, I would have been so mad.
Okay, so then
I don't.
we're just going to divide both sides by 24. And we get that P equals what? 8.6. Okay. All right. And that's the solution. So you guys do letter B. Okay. Because percents can be expressed as ratios, you can use the proportion. A percent over 100 equals a part over the whole to solve percent problems. So reminder that a percent is a ratio that means per 100. So here we have a percent problem. It says a poll taken one day before an election showed that 22.5% of voters plan to vote for a certain candidate. If 1,800 voters participated in the poll, how many indicated that they plan to vote for that candidate? So since it's a percent problem, we can use this ratio here then that says the percent over 100 equals the part over the whole. And the thing we need to find out is then, what's the percent, what's the part, what's the whole? So in this case, what's the percent? Okay, and so when it says the percent, we are actually going to use 22.5. We are not going to use 0.225, all right? That's a situation where we don't move the decimal. We use it as it is, because dividing by 100 actually takes care of that for us. So they give us one other number here. They give us 1,800. Is that number the part or the whole? Okay, because it says it was 1,800 voters. So then we're going to put the 1,800 in the denominator, and then the part, or x, in the numerator. And then we'll cross multiply and solve. So we get 100x equals, what was it? 40,500? Is that right?
It's 400, isn't it?
So 40,500 is the number we get 22.5 times 1,800. Right, then when we divide by 100, we'll get x equals 405, and that is what? The people who voted for the candidate, right? 405 people voted for the candidate. Now that's one method of doing it. The other method of doing it is using a percent equation, which basically the percent equation is kind of like taking this right here and using it as, writing it as an equation instead, where the percent times the whole is equal to the part. So, but we'll take the percent as the decimal, and we'll multiply that times the whole to get the part. Right, so we change it to 0.225 times 1800 will equal our value of x. And still, is that going to give us the same thing? Definitely will, 405. So you actually have two different ways you could do it. You could set it up as a proportion, where you have the percent over 100 equals a part over the whole. Or you can take the percent as a decimal, multiply it by the whole, and then that will give you the part. Okay, rate problems are also something that involves ratios. And what are some different types of rates that you guys work with? How many people drive a car? Okay, all right, what's one of the rates that you pay attention to? Okay, miles per gallon and miles per hour, most importantly, okay? If you're a runner, you probably pay attention to, it's probably meters per second then, right? Do we have any track people in here? Okay. Caleb, what do you do in track? Okay, you're sprinter, so you do the 100, 200, 400. Okay, so you pay attention to how many meters per second you run then, right? Okay, that's very important. Right? So here we've got this guy named Ryan. He ran 600 meters and counted 482 strides. How long is Ryan's stride in inches? So we need to figure out how long one of his strides are, right? And then we can find out how many inches it is. So he ran 600 meters and 482 strides. So how can we figure out how long each stride is then? Okay, so we'll do 600 divided by 482. All right, so we take 600 divided by 482. All right, oh, look at that. You got it right there. Okay. So it's 1.24 meters per stride then. So how do I figure out how many inches that was?
7.3.
Do I divide by 39.37 or multiply by it? Okay, because if inches was bigger, we would divide, but since it's smaller, we're going to multiply. Okay. And we get that Ryan's stride length is approximately 49 inches. Okay. So notice the conversion. Right? We have 1.24 meters for one stride here. Okay. And then we're multiplying it by 39.37 inches per meter. Notice, where are the meters at? In the numerator here, and then in the denominator there, so we can cancel the meters out so that we're left with inches when we're done. Okay. All right, so, all right, similar figures. So when figures are similar, what does that mean to you? They're not the same. Okay, they're close to being the same. What things are the same?
The shape.
Okay, the shape is the same, which means that one specific part of the shape is exactly the same. What is it? Is it side lengths or angles? Angles. The angles are all the same, but the side lengths differ by what's called scale factor. Okay? And so when we find the scale factor, that tells us how much bigger the one is than the other. So here we have triangle XYZ. It has vertices at the origin, 0, 0, down here, and at negative 6, 9, which is over here, and back here at 0, 9. So this triangle XAB is similar to triangle XYZ with a vertex at B at 0, 3. All right, so we got to add that vertex in here at 0, 3. It says graph XYZ and XAB on the same grid.
Baseball and softball players out at this time for their games. Varsity softball and baseball.
Okay, so we are going to then we have to find b. All right, and it's all a matter of using ratios. So we're going to compare side lengths then. So we've got the length of this side here from x to b. So let's label this. This is x. This is b. And we need to find out where a is going to be at. Okay. So how far is it from x to y up here? From x to y is how far? 9. And from x to b is 3. Okay. So we can do from x to y over x to b. Now the question is, where is a at? So are we going to go from x to a, or are we going to go from b to a when we're trying to find it? Okay, b to a. Since x to a is an angle, then we need to use b to a. Well, we know that the distance from y over here to z, okay, we know what that is, right? Okay, that is 6, so that's something we know. So we know from y to z, and we want to find from b to a. So we're talking about lengths, right? So all the lengths have to be positive, okay? They have to be positive. So let's plug in what we know. We know the distance from x to y is 9. From x to b is 3. From y to z, it's 6, right? It's a distance, so it's positive. What we don't know is the distance from b to a. All right, so here's where we're going to use our proportional reasoning to find that answer then. Okay, well, 9 is how many times bigger than 3? 3 times bigger, so 6 is 3 times bigger than what? 2. Right? So this would be, my point is right there. So here is my triangle that would be for x, a, and b. Okay. That make sense?
So basically you just go until you hit the other triangle's line.
Pretty much, as long as it's, but it has to match as far as the scale factor. So triangle XYZ, all of the lengths of that triangle are 3 times more than the length of the other one. So if I could figure out what the distance is from x to z, which I think this was supposed to be y, but I made it z. Okay, the distance from here to here, well, the distance from x to a should be 1/3 of that then. Okay, so you're looking at comparing the shapes. Indirect measurement uses known lengths, similar figures, and proportions to measure objects that cannot easily be measured. So here we have a tree in front of Luca's house. It casts a 6-foot shadow at the same time as the house casts a 22-foot shadow. If the tree is 9 feet tall, how tall is the house? Now let me ask you this question, because this always comes up. Where do you see shadows? On the ground, okay? Anybody ever seen a shadow be the hypotenuse of a triangle? Usually when you see a shadow, it's on the ground, right? Okay. So when you draw a picture, okay, make sure shadows are always on the ground, not on the diagonal, okay? Because that would just be wrong. All right. So here we got, what we got? We got Luca's tree. All right. So here's his tree. All right. Luca's tree casts a 6-foot shadow. So we've got this right triangle here. All right. So this is 6 foot. And Luca's tree is to tell us how big Luca's tree is. Okay, 9 feet tall. All right. And then here we have Luca's house. Here's his house. Here's the door. All right, he's got a little window up here. All right. And this casts a shadow that is. What's that? Oh, we're looking that way. They can't? Doesn't matter. Doesn't matter. All right, we'll redraw it just for Spencer. Okay. All right. Just for you. All right. So, well, hold on a second. Hold on. All right. So here's the sun out here. Then is that what you're saying? All right. Okay. There we go. All right. So we have similar triangles, right? So we have the shadow for the tree, which is 6 feet, over the shadow for the house, which is 22 feet, is equal to the height of the tree versus the height of the house. All right? So we just set up a proportion, and then we can cross multiply, and we get what, Jesse? 33. All right, so the house is 33 feet tall. Okay. All right.